Hi, folks. What we're going to look at right now is we're going to look at the summary of a rice on a chessboard. Okay, this is applications of exponential functions R10. So here we go.
This is an old story, but it reminds us of the surprises we can get when even a small number like 2 is multiplied by itself many times. King Shahram of India was so pleased when his Grand Vizier Sisabendar presented him with the game of chess that he asked Bendar to name his own reward. The request was so modest that the happy king immediately complied. What the Grand Vizier had asked was this: that 1 grain of wheat be placed on the first square of the chessboard, 2 grains on the second square, 4 on the third, 8 on the fourth, 16 on the fifth square, and so on, doubling the amount of wheat on each succeeding square until all 64 squares were accounted for. When the king's steward had gotten to the 17th square, the table was well filled. By the 26th square, the chamber held considerable wheat, and a nervous king ordered the steward to speed up the count. When 42 squares were accounted for, the palace itself was swamped. Now fit to be tied, King Shahram learns from the court mathematician that had the process continued, the wheat required would have covered all India to a depth of over 50 feet. Incidentally, laying this many grains of wheat end to end also does something rather spectacular. They would stretch from the Earth, beyond the Sun, past the orbits of the planets, far out across the galaxy to the star Alpha Centauri, 4 light years away. They would then stretch back to Earth, back to Alpha Centauri, and back to the Earth again.
All right, so that was a fun little story that just kind of showed you the power of math and the power of exponential functions and growth. So in your own words, it would be good for you to summarize the story here. I'm going to continue on with example 1. I'm going to look at this photographer. He uses filters to change the look of photographs that she takes. A particular filter that she uses reduces the light transmission through it by 15%. So that means 15% is blocked out. And the photographer may or may not use one or more of these filters at one time. Things to consider. We're doing percents. So when we're using percents, you want to convert them to decimal before you use the number in equations. And to do that, you divide by 100, or you simply just move the decimal place over twice so that it ends up right over here. And then you could use that in your equations. So total light is going to be 100%. That's if nothing's blocked. So all of the light goes through, your base would be 1. Now here we're blocking 15%, so we're blocking 0.15 out of a whole, and the light that's allowed to pass through out of each filter is 85%, so we're going to use 0.85. That's why our equation ends up being P equals, and in brackets, 0.85, all to the power of n. N is the exponent. N is the number of filters that is going to be used. It says here, graph the function, use the graph to estimate the number of filters needed to reduce the light transmitted to half the original intensity. Now, if we look at this right here, I've created a table of values so that I can get the numbers, and I just used a simple calculator to do so. At 1, here, this is n equals 0. So at n equals 0, I end up getting 1. So that means no filters are being used and all the light is passing through. Here, if you're using one filter, you end up with 85% of the light passing through. 2, 3, 4, 5 filters, and so on. So we want to see what is going to allow half the original intensity. So what I'm going to look for is over here, this is my half mark. I'm going to read across until I hit the line. Now, this is my hand-drawn graph, so it's not as accurate as a computer-generated one will be. And then I look down at the number of filters and I come across that it's at around 4. So I can safely say that you will need 4 filters to block out approximately 50% of the light. Okay, now in the next 2 examples I'm going to do in the next video. So hang tight and see you soon.